The next thing that we want to look at in this module is how IPv6 addresses are structured. Now, IPv6 addresses are represented a little bit differently than IPv4 addresses. We represent these in hexadecimal, and you can see here that the address space is quite a bit larger. It's a 128-bit address. Now you can see we've also got a mask here, /64. What that's telling me is the first 64 bits of this 128-bit address are network bits, and the last 64 bits are host bits. So there's our IPv6 address. It is 128 bits with a 128-bit mask. That's what that /64 is. And we can break this down into binary as well, but it is represented as a hex value. Now, it's helpful to understand hex when you're working with IPv6 addresses. So for example, if we took this 2001 address, let's just take the 2 value there. That 2 value and the 0 and the 0 and the 1, that's actually a total of 16 bits in that field there. So the 2 would be represented with the 4 bits 0010. So now if we use those bit values as we saw in the last section on IPv4, then that bit value that's enabled right there of a 1 would be the 2-bit value. And so 0010 equals 2 if we were to convert that to a decimal value. Now the 0 value here, all zeros, that was pretty easy. We're going to do the same with this 0, nothing special there. And then the 1 would be 0001. So that's pretty easy to break that down and to figure out how that address appears. So that bit value, all 16 of those bits, equals 2001. Now let's make things a little more difficult here. We have the 0db8. Now this is interesting because we have letters in the address. And the reason for the letters in the address is because once we get up to the number 9, the next value, if we were to look at a binary to a decimal conversion, the next value would be the number 10. However, we don't have the ability to write or to notate the number 10 in this field 0db8. You get a single value. So once we get to 9, we have to then move to letters to indicate a binary value. So what would be the representation of the binary value 10? Well, in hexadecimal, like I said, we can't use 10, so A would be the equivalent to 10, and then B would be the equivalent to 11, C would be the equivalent to 12, and so on. So 0db8, we would take all zeros for that first portion. 1101 would be D. 1011 would be the B. And 1000 would be 8. And that's how we represent those 16 bits in binary